Last class we discussed four properties of the determinant. Today we discuss another four properties of a determinant. Property 5. If every elements of a row or a column can be expressed as the sum of two numbers, then the determinant can be expressed as the sum of two determinants. Now we prove it. We know that A1, B1, C1, A2, B2, C2, A3, B3, C3, A1 whole into B2, C3 minus C2, B3 minus B1 whole into A2, C3 minus C2, A3 plus C1 whole into A2, B3 minus B2, A3. Let it A1 plus alpha, B1 plus beta, C1 plus gamma, A2, B2, C2, A3, B3, C3 is a determinant whose every elements of a first row represent as the sum of two numbers. Now we expanded it. We show that this determinant is the sum of two determinants. Now A1 plus alpha, B1 plus beta, C1 plus gamma, A2, B2, C2, A3, B3, C3, that equal to A1 plus alpha whole into B2, C3 minus C2, B3 minus B1 plus beta whole into A2, C3 minus C2, A3 plus C1 plus gamma whole into A2, B3 minus B2, A3. Okay, that equal to A1 whole into B2, C3 minus C2, B3 minus B1 whole into A2, C3 minus C2, A3 plus C1 whole into A2, B3 minus B2, A3. Okay, plus alpha whole into B2, C3 minus C2, B3 minus beta whole into A2, C3 minus C2, A3 plus gamma whole into A2, B3 minus B2, A3. Okay, this is the expansion of the determinant A1, B1, C1, A2, B2, C2, A3, B3, C3 plus this is the expansion of alpha, beta, gamma, A2, B2, C2, A3, B3, C3. Okay, so we prove if every elements of any two rows or columns of a determinant can be expressed as the sum of two numbers, then the determinant can be expressed as the sum of two determinants. Okay, now we take an example. Verify 2 plus 5, 4 plus 6, 6 plus 7, 1, 3, 5, 7, 1, 6 is equal to 2, 4, 6, 1, 3, 5, 7, 1, 6 plus 5, 6, 7, 1, 3, 5, 7, 1, 6. That okay. Now we verify it. Answer LHS equal to 2 plus 5, 4 plus 6, 6 plus 7, 1, 3, 5, 7, 1, 6. Okay, 7, 10, 13, 135,716, that equal to 7 into 18 minus 5 minus 10 whole into 6 minus 35 plus 13 whole into 1 minus 21, that equal to 7 into 13 minus 10 into minus 29 plus 13 into minus 20, that equal to 91 plus 290 minus 260, okay, that equal to 381 minus 260, that equal to 121, okay, that equal to 121. Okay, now we find the RHS of this verification. RHS equal to this, that equal to 2 whole into 18 minus 5 minus 4 whole into 6 minus 35. First we find this expansion of this determinant plus 6 whole into 1 minus 21 plus 5. Now we expand the second determinant, 5 whole into first row is 5 whole into 18 minus 5 minus 6 whole into 6 minus 35 plus 7 whole into 1 minus 21, okay, that equal to 2 into 13 minus 4 into minus 29 plus 6 into minus 20 plus 5 into 13 minus 6 into minus 29 plus 7 into minus 20, okay, that equal to 26 plus 116 minus 120 plus 65 plus 3 plus 6 into 9, 54, 4, 5, 174 minus 140, that equal to 381 minus 260, that equal to 121, okay, 121. So LHS equal to RHS. So LHS equal to RHS. Okay. Now we prove property 6. Property 6. Okay. A determinant remains unchanged by adding k times the elements of any row or column to the corresponding elements of any other row or column where k is any given number, where k is any given number. This property says that a determinant remains unchanged by adding k times k is any number, given number, maybe 2, 3, 4, 5, etc. Time k times the elements of any row or column to the corresponding elements of any other row or column, where k is any given number. Now we prove it. Okay, prove. Okay, let a1 b1 c1 a2 b2 c2 a3 b3 c3 is a determinant. Okay, let a1 plus kb1 a2 plus kb2, we write it in column wise, a3 plus kb3 b1 b2 b3 c1 c2 c3 is a determinant which first column represents the sum of first column elements and k times of second column elements, k times of second column elements. Okay, now we show that this determinant is equal to this. Okay, now a1 plus kb1 b1 c1 a2 plus kb2 b2 c2 a3 plus kb3 b3 c3. Okay, that equal to, by using the property 4, since the first column element represents the sum of two numbers, then it represents sum of two determinants. So we have a1 b1 c1 a2 b2 c2 a3 b3 c3 plus kb1 b1 c1 kb2 b2 c2 kb3 b3 c3. Okay, by property 5. Okay, next, since the first, every element of first column of this determinant multiplied by a factor k, then we outside the determinant. Okay, by property 4, so we write a1 b1 c1 a2 b2 c2 a3 b3 c3 plus k whole b1 b1 c1 b2 b2 c2 b3 b3 c3. Okay, by property 4. Okay, so by we write A1, B1, C1, A2, B2, C2, A3, B3, C3 plus K into 0. The value of this determinant is 0 because the first column and second column elements are identical. By property 3, the value of this determinant is 0. By property 3, okay, that equal to A1, B1, C1, A2, B2, C2, A3, B3, C3 plus 0, that equal to only the determinant A1, B1, C1, A2, B2, C2, A3, B3, C3. Okay. Now we prove it. Now, so the determinants remains unchanged by adding k times the elements of any row or column to the corresponding elements of any other row or column. Okay. Now we take an example. Verify 2 plus 3 into 4, 1 plus 3 into 3, first column element, 7 plus 3 into 1, 4, 6, 3, 5, 1, 6. That equal to 2, 4, 6, 1, 3, 5, 7, 1, 6. Now we verify that this determinant is equal to this. Okay. Now we take left hand side of this verification. Answer LHS 2 plus 3 into 4, 4, 6, 1 plus 3 into 3, 3, 5, 7 plus 3 into 1, 1, 6. Here K is 3. Okay, here K is 3. That equal to 14, 4, 6, 10, 3, 5, 10, 1, 6. Now we expand it. 14 into 18 minus 5 minus 4 into 60 minus 50 plus 6 whole into 10 minus 30. Okay, that equal to 14 into 13 minus 4 into 10 plus 6 into minus 20. Okay, that equal to 182 minus 40 minus 120. That equal to 182 minus 160. That equal to 22. That equal to 22. Now we take a right hand side of this determinant. RHS. Here we write 2, 1, 7. Now we expand it. 2 whole into 18 minus 5 minus 4 whole into 6 minus 35 plus 6 whole into 1 minus 21. Okay, 2 into 13 minus 4 into minus 29 plus 6 into minus 20. Okay, that equal to 26 plus 116 minus 120, that equal to 146, 126, 18, 26, 116, 146 minus 116, 2 in 18 minus 5 minus 4, 60 minus 35 plus 6, 1 minus 21, that equal to 142. Okay. 142 minus 120, that equal to 22. Okay. 142 minus 120, that equal to 22. Okay. So LHS equal to RHS. Okay. Now we prove seventh property. Property 7. The sum of the product of the elements of any row or column of a determinant, sum of the product of the elements of any row or column of a determinant and cofactors of the corresponding elements of any other cofactors of the corresponding elements of any other row or column of a determinant is zero. The sum of the product of the elements of any row or column of a determinant and cofactors of the corresponding elements of any other row or column of a determinant is 0. Okay. Now we prove this property. We know that A1, B1, C1, A2, B2, C2, A3, B3, C3, that equal to A1 capital A1 plus B1 capital B1 plus C1 capital C1, where A1 is equal to B2 C3 minus C2 B3, B1 is equal to C2 A3 minus A2 C3, and capital C1 is equal to A2 B3 minus B2 A3 are the cofactors of small a1, b1 and c1 respectively. Okay. Now we saw that the elements of second and a sum of the product of the elements of a second and a third row with this cofactor is 0. Now A2 A1 plus B2 B1 plus C2 C1, that equal to A2 whole into B2 C3 minus C2 B3 plus B2 whole into C2 A3 minus A2 C3 plus C2 whole into A2 B3 minus B2 A3. Okay, that equal to A2 B2 C3 minus A2 C2 B3 plus B2 C2 A3 minus B2 A2 C3 plus C2 A2 B3 minus C2 B2 A3. Okay, that equal to all terms are cancelled, we get 0. A2 B2 C3, that equal A B2 A2 C3, A2 C2 B3, C2 A3 A2 B3, B2 C2 A3, C2 minus C2 B2 A3. Okay, similarly A3 A1 plus B3 B1 plus C3 C1 is equal to 0. Okay, now we take an example. Consider a determinant 2 4 6 1 3 5 7 1 6. Cofactors of elements first row of first row elements are C11, that equal to plus of 3 5 1 6, C plus of 3 5 1 6, that equal to 18 minus 5 13, C12, that equal to minus of 1 5 7 6, that equal to minus of 6 minus 35, that equal to minus of minus 29, that equal to 29, C13, that equal to plus of 1371, that equal to plus of 1 minus 21, that is minus 20. Okay, now 1 into C11 plus 3 into C12 plus 5 into C13, that equal to 1 into 13 plus 3 into 29 plus 5 into minus 20. Okay, that equal to 13 plus 87 minus 100, that equal to 100 minus 100 equal to 0. Similarly, we can show 7 into C11 plus 1 into C12 plus 6 into C13 equal to 0. Okay, now we prove property 8. Property 8, if all the elements below the leading or diagonal elements or above the leading or diagonal elements except the leading or diagonal elements are zero, then the value of the determinants equal to the value of the determinants becomes equal to the product of all the leading or diagonal elements. Okay, if all the elements below the leading or diagonal elements or above the leading or diagonal elements are zero, then the value of the determinant is equal to the product of the diagonal elements. Now we verify it using an example. Verify A1 B1 C1 0 B2 C2 0 0 C3 that equal to A1 B2 C3 that equal to A1 0 0 B2 C2 A2 B2 0 A3 B3 C3 that also equal to A1 B2 C3. Answer. Now A1 B1 C1 0 B2 C2 0 0 C3 that equal to A1 whole into, if we expand it first row well, then we have B2 C3 minus C2 0 that equal to 0 minus B1 whole into 0 minus 0 plus C1 whole into 0 minus 0. Okay, that equal to A1 B2 C3. Similarly, we can show A1 0 0 A2 B2 0 A3 B3 C3 that equal to A1 B2 C3. Okay, these are the 8 properties of the determinants. Okay, next class we discuss another topic. Okay, thank you.